Okay, today we're in lesson 3.3, interpreting the unit rate as slope. Interpreting the unit rate as slope.
All right, let's take a look at an application together. So the table shows the distance traveled over a certain period of time, and our challenge is to use the data to make a graph, and then find the slope of the line and explain what it shows. So here's the table of data. We have time in minutes, and we have distance in feet, and let's plot away. I'm going to plot on the x-axis time, so I'm actually going to label that here. This is going to be time in minutes, and here we're going to have distance in feet. It's always good to label your axes so you sort of know where everything is. All right, now let's plot some points. So we've got 10. We're at 25,000. It's 20,000, 25,000. 20, we're at 50,000. 30, we're at 75,000. That's 75. 40, we're at 100,000. Wow. And it certainly seems like we have a straight line. We connect these points. Connect these points very nicely. We see this great straight line. Now, given this, I want to now find the slope. So what's the slope of this line? Well, the way to think about this is the slope. I'm going to, of course, need 2 points. So how about if I pick this point for one point and this point for my other point? All right, so now I've got to consider, remember the formula for slope is rise over run. So I look at the change in y over the change in x. So change in y, I'm going to take this y value minus this y value. So I'm going to have 50,000 minus 25,000. And divide that by, now here's a great mistake, I could take 10 minus 20, but that's not right. The x value that I write first has to correspond to the first y value, which in this case is 20 minus 10. You can always check to see if you're okay by just covering up. 10 comma 25,000, is that a point? 10 comma 25,000, yep. And what about 20 comma 50,000? 20 comma 50,000, yep. So this is correct. 50 minus 25 is 25,000. And then 20 minus 10 is 10. And so when we divide, actually, we see 2,500. So that's the slope. And now, what does it represent? Well, it represents the rate, right? This, of course, remember, is table showing distance traveled over time. And so this actually tells us that this object was traveling at a constant rate of 2,500 feet per minute. And so the slope represents the rate or the speed that the object was traveling. Obviously, this is a very, very fast-moving object, but it is traveling in a way that has constant speed, and therefore we see a linear graph. Neat. Anyway, enjoy thinking about slope. Thinking about slope, in fact, really is at the heart of thinking about straight lines. I'll see you soon.
Graphing proportional relationships. You can use a table and a graph to find the unit rate and slope that describes a real-world proportional relationship. The constant of proportionality for a proportional relationship is the same as the slope. Example 1, based on the previous video. Every 3 seconds, 4 cubic feet of water pass over a dam. Draw a graph of the situation. Find the unit rate of this proportional relationship. All right, now our first step is to make the table. Every 3 seconds, 4 cubic feet of water pass over a dam. Every 3 seconds, 4 feet. 3 seconds, 4 feet. So now that's 3 seconds. If we add 3 seconds to 3 seconds, we're at 6 seconds. So with 6 seconds, now we're at 8 feet, or 2 times 4, which is 8, because 6 is twice as big as 3. All right, now we're at 9. So 6 plus 3 gives us 9. So now we're at 9 seconds. So at 9 seconds, it's going to be 4 more. 8 plus 4 is 12. 9 plus 3 gives us 12 seconds. All right, that means we're going to add 4 to this one. 12 plus 4 is 16. 12 plus 3 is 15 seconds. So now we're at 15 seconds. That means we add 4 to 16 for 20. All right, so we just made our table. Once again, what was it based on? Every 3 seconds, 4 cubic feet. Okay, next we got to draw our graph. All right, when we draw our graph, we're recognizing that time is our x value and that volume is our y value. Once again, time is independent and y is dependent. All right, so our first coordinate is 3, 4. X is 3, y is 4. So x is 3 would be right here. On the bottom, they're counting by 2s. 2, 4, 6, 8, and 10. Also, as they go up and down, they're also counting by 2s. 2, 4, 6, 8, and 10. So once again, our first values are 3 and 4. X is 3, y is 4. That's about right there. All right, so that's 3 and 4. Our next value is 6 and 8. So x is 6, 2, 4, 6. Y is 8. That's going to be about right there. Once again, 2, 4, 6, 8. Our next point, 9 and 12. X is 9, y is 12. Let me see, 2, 4, 6, 8, 10. So 9 is right there. We go up until we get to 12, and 12 is about right there. So now we're at 9 and 12. That's that point right there. Next, we got 12 and 16. X is 12, y is 16. So 10, 12. We go up, and there is 16 right there. All right, so that's 10, 12, 14, 16. 12 and 16. All right, last but not least, we got x is 15 and y is 20. X is 15, that's 10, 12, 14, 16. So 15 is in the middle, and we go up till we get to 20. All right. All right, and that's that point right there. And don't forget that was 12 and 16. All right, so now we've graphed our table. Okay, step 3, find the slope. Slope is equal to the rise over the run, which in this case is going to end up being 8 over 6, which is going to reduce down to 4 over 3. Now let's make sure we count properly. All right, let's do the rise first. If we do the rise, we end up going 1, 2, 3, 4. But don't forget, we're counting by 2s. So what's 4 times 2? 8. If we do our run, we end up going 1, 2, 3. 3 times 2 is 6. So our run is going to be a positive 6. So then our slope, rise over run, is 8 over 6. Reduce that down to 4 over 3. Now we could have came out with 4 over 3 just by going 1, 2, 3, and 4, and then 1, 2, 3. But you got to know how to do both. All right, you got to know how to do both. especially when you have to interpret the graph. As a review, don't forget, you could have also found the slope going this way or that way. Answer would be the same. 1, 2, 3. That's for your x. That would be a -3. And then for your y, you would be going down. That would be 1, 2, 3, 4. That would be a -4. But a -3 divided by a -4 divided by a -3 will still give you a negative divided by a negative, which is a positive, and it will still give you 4/3. Here, if you went up, it'd be a +4, and across would be a +3. So we get the same thing. So after making our table, drawing that graph, and finding the slope, we find the unit rate of water passing over the dam and the slope of the graph of the relationships are equal, 4/3 cubic feet per second.